All right, so we're going to be doing an Archimedes screw and build123d. If you want to get that set up, you can check links in the description, but I'm just gonna get right on it. So we're gonna import show camera. This is for viewing, and then for build123d, we're just gonna import everything. And as long as you're using just these two, none of the packages should conflict, but if you need to, you can change the names as needed. All right, so let's start with our dimensions. So let's start with the shaft. Let's say we want the radius. Let's set it equal to, let's say, 25. And our shaft height can be, let's say, 1,000 because we want it to be significantly longer. And we can come back to the dimensions later. For now, let's start loading. So we probably, shaft is going to be a cylinder. So let's do that. We can name this Archimedes, as we're doing screw, and then let's create our cylinder. Okay, so a cylinder we define as the radius, the height, and by default the rotation is 0, and it's a full cylinder, and alignment is going to be at the center of all the axes X, Y, Z. So let's set the radius as shaft radius, and let's set the height as shaft height. And then let's run this. Ah, I forgot to, let's display it. So let's use the show from, and we want to display Archimedes, and let's set a reset camera. What this does is whenever we rerun the code, it'll give us a nice isometric view by default. Okay, and let's see. So we can see X, Y, Z, and it's in the middle, centered along all of them. Okay, so now that we have our shaft, we probably want to build, first let's draw the line path for our blade. So let's build our helix. So this is going to be a line. We can just name it helix. And now we can just define the helix. And right, I'm building it inside its own build line box so that at the end, we'll just see the entire Archimedes screw just by itself without all the extra lines. But if you want to, you can just define the helix here and it'll also be fine. But for now, let's see. All right. So our helix comes with a pitch, a height, and a float. So our height is going to be shaft height, and then so we need its own radius for the blade. So let's set that. So this is going to be for the blade. So blade pitch, let's say 400. Blade radius, let's say 250. All right, and let's see. So let's set pitch equals the pitch, and then height is going to be same as the shaft height because we want it to follow. And then it's going to be radius as the blade radius. All right, so since this is its own box, we will need to add this. And let's run it. Alrighty, and so we can see it here, and we can see that by default the helix uh, starts at 0, 0, 0, which is right here, but our cylinder is aligned at the center. So let's change the alignment of the cylinder, and let's do we can keep, so basically we want to move the Z up. Okay, so this is going to, so we can keep the X and a Y aligned at the center, but we are going to align the Z at the minimum, which is 0. Um, so let's run that, and there we are. Now they're all nicely aligned. Okay, so now that we have our path, we can we can build a profile. Let's say starting here, we're going to want a rectangle, so we can make our blade. So let's do our blade profile, and this is going to be a sketch. We can call it blade profile. Oops, and ignore that. And where do we want it? Let's say we want it down here, and we want it to go from this radius to this radius. So let's set up the start point. So the start point is going to be this point, which is the shaft radius, and then the Z can be 0. Okay. And so at this location, we're going to draw our rectangle, and rectangle is defined by with height. We don't want any rotation, and then let's see. Okay, so our width is going to be the big radius, so the blade radius, minus the smaller radius, which is the shaft radius, and then our height. Let's define blade thickness. Let's make it 15. And so this can be our blade thickness. Alright, so let's see how, and let's add it here. Let's add it to the display and rerun it. And okay, so this is not where, this is currently on the XY plane. So let's change the plane. We want the XZ plane. And we also notice that it's aligned, it's not properly aligned because it's treating this point as the center. So let's change the alignment of the rectangle. Let's align it. So this is going to be the X. I think we want it to align right there. And then in terms of the Z, seems fine. We can do it halfway, so we can keep that as the default, which is I think for all of them it's going to be aligned, center aligned. Okay, and there we go. Instead of treating this point as the center, it now treats it as the minimum, as the starting point. Cool. And so now we're going to want to sweep this. If you want to change the value here, you can do it, make it more thick. I think this looks good to me for now. And so let's do our sweep. have a nice function for that, and your path is going to be along this helix, and we will want to include is friend is true, but let's just see, because or else it doesn't close the shape properly and it gets a bit confused. But let's just see for now. We have our nice Archimedes Screw. And if we want to, we can remove these. Since the sweep is not in its own box, it will automatically be added. Um, that's uh, that's the determining factor. Um, and then yeah, and so let's say we wanted to export this as we can export it as a step file. Let's say we would export. We can export Archimedes and we can name it Archimedes Screw.step, and then if we run it, we oh, uh, we do need to specify that we are exporting the part because it does store a bunch of other data that, and it only works on exporting the part. But if we go here, we then have our step file, and you can import this into your favorite CAD program and continue post-processing it however you like. There, and that's all.